lines. Tell them read between it. Tripping while I'm slipping, busy fighting all these demons. Listen while I'm spitting, bark, you probably won't believe it, but life is.
Hey guys, and welcome back. So now we are on to 4.4. We are more than halfway done with this unit. And today we are going to be looking at proving lines are parallel. So one is that I can prove that the converse of the parallel lines and transversal theorems. So basically that you can prove lines are parallel given some information. And that you will also be able to solve problems using these converse theorems. All right. So let's get started, guys. So the first converse theorem is the converse of the corresponding angles postulate. So remember, the corresponding angles postulate was that if we have two parallel lines, then the corresponding angles are congruent. Now remember, the converse is instead of if P then Q, it's now if Q then P. So it's saying if the angles are congruent, if the corresponding angles are congruent, then the lines are parallel. So if corresponding angles are congruent, then the lines cut by the transversal are parallel. So remember, this is the postulate. This is the one that we assume as true. Now, these next three are all theorems. We can prove these. And so the first theorem is that if alternate interior angles are congruent, then the lines cut by the transversal are parallel. So we can conclude that R and S are parallel. So that's why it's really important that we're able to identify alternate interior angles and know that if they are congruent, then the lines are parallel. Next one, converse of the alternate exterior angles theorem. If alternate exterior angles are congruent, then the lines cut by the transversal are parallel. So you can say if alt exterior angles congruent, then lines parallel. Okay. So it's here, if we're saying that 5 and 6 are are congruent, then we can conclude that R and S are parallel. So the conclusion for the converse ones are that the lines are parallel. The lines are parallel. The conclusion is that the lines are parallel. All right, the last one that we're going to go over is converse of the same side interior angles theorem. And quite honestly, you can also say that it's the converse of the same side exterior angles theorem as well. They both work the same way. So if same side interior angles are supplementary, so if we have same side interior angles that are supplementary, then the lines cut by the transversal are parallel. So if these two are supplementary, then the lines cut by the transversal would be parallel. So if the measuring angle 3 plus the measuring angle 2 equals 180 degrees, then you know that the lines are parallel. All right, so enough theorem talk, and let's get into some problems, some examples. All right, so it's given to us that angle 4 is congruent to angle 8. How can we prove that line L is parallel to line M? Well, we know, whoa, it kind of went for me there. We know that angle 4 and angle 8 are corresponding angles, and we know that angle 4 and angle 8 are congruent because it's given to us. And so since by the definition of corresponding angles, we know that they're corresponding angles and that it's given to us, we can conclude that angle L and angle M are converses of each other. Oops. Angle L and angle M are parallel to each other because of the converse of the corresponding angles postulate. Next, we have angle 5. Angle 1 is congruent to angle 5. Angle 1 is congruent to angle 5. Why would this be the case? Well, angle 1 and angle 5 are alternate exterior angles, and if the alternate exterior angles are congruent, then we can say that R and S are parallel by the converse of the alternate exterior angles theorem. And then example 3, we want to prove that R and S are congruent. We know that 2 is equal to 10x plus 8, and the measure of angle 3 is equal to 25x minus 3. and we know we're also given that x is equal to 5. So since these are same side interior angles, we're trying to prove that these would be supplementary. So let's see what, if we substitute in 5 in for x, we get that the measure angle 2 is 58 degrees. And if we substitute 5 in for x for 25x minus 3, we get that the measure of angle 3 is 122 degrees. And if we add them together, what do we got? Bibbidi bobbidi, 180 degrees. So since they add up to 180 degrees, R is parallel to S by the converse of the same side interior angles theorem. Yeah, we are moving, guys. All right, so those are our 3 examples. Now let's do one more where we're proving. So we have that lines P and R are parallel. We know that's to be the case. We need to prove that lines L and M are parallel. Okay, so it's given to us that P and R are parallel to each other. And so we can say that angle 3 and angle 2 are congruent by the converse of the alternate exterior angles theorem. Oh, sorry, not the converse, because we know that the lines are parallel, and we're finding the angles, so therefore it's simply the alternate exterior angles theorem. Then we can say angle 1 and angle 3 are congruent, because that's given to us. And then angle 1 and angle 2 by the transitive property of congruence. See, because 2 is congruent to 3 and 3 is congruent to 1, therefore 1 and 2 must be congruent. And since angle 1 and angle 2 are congruent to each other, we can say that the lines are parallel by the converse of the corresponding angles postulate. All right. On to the next one. All right, so now just name the postulate or theorem that would prove lines P and R congruent. So angle 4 and angle 5 are congruent. Which theorem would we use to prove that P and R are congruent? Converse of the alternate interior angles theorem, because these are alternate interior angles and they are congruent, therefore these lines are parallel. All right, angle 2 and angle 7, converse of the alternate exterior angles theorem. And angle 3 and angle 7, converse of the corresponding angles postulate. So the corresponding angles one is a postulate because we are assuming it as true. Next, we have angle 3 and angle 5 are supplementary. So that would be converse of same side interior angles theorem, because the same side interior angles are supplementary. And then just one last slide. This is kind of a precursor to when we come back to 4.6. So through a point P, not on a line. So if we have a point, if we have a point and a line, there is exactly one line that is parallel. So there's only one line that can be parallel, through this line that goes through this point. All right? The parallel postulate guarantees that for any line L, you can always construct a parallel line through a point that is not on L. So you can always construct a parallel line to any given line. All right, that's it. This one was relatively short. Thank you guys. Have a good evening.